I'm Gabor BENEDEK. As said, a QA and DevOps lead at Morgan Stanley with pretty much 10 years experience in the field. The fact that I'm here presenting an IT topic kind of indicates that I'm a technology geek. I love coding. I like to connect various IT solutions together, such as QA and observability. That's the topic for today. But I swear, from time to time, I also go offline. In fact, I have a beautiful family with two very mischievous daughters, 2 and 4 years old. And actually, they lent me one of their toys for the today's session, a magical pen. It has invisible ink inside of that. We are going to have a little bit of fun with that. Stay tuned. But before, let me introduce my topic. It is the story of mine, how I extended my standard pre-production testing practices with observability solutions. And why I've done that? Because exhaustive testing is not possible. Hands up if you heard this sentence already. Yeah, I accept it for the same. So either from experience or from the book, many of us know that this is a huge risk, and one of our job as a QA engineer is to mitigate that. And yeah, this was published by the ISTQB organization through the 7 principles of testing. Now, I pull back this magical pen because in this game, consider my hand as my main software product. I've been using a couple of decades by now. And before I came to the stage, I've implemented a new functionality on that, a hidden secret message only for you. And if you are ready for seeing this message, let me just reveal it to you. So, hello, stuff. Welcome, everyone. I hope you are ready for having a good time with me today. If you were far away, don't worry, just look up at the screen. That was on my hand. I've done the very same thing on my other hand with one small difference. I did it in the morning. And since that, I made a whole bunch of production interactions with my other hand. And if you are ready for seeing that message too, I'm going to reveal it. So, hello, Gustav. What's wrong? Oh, OK. It looks my message didn't survive production, right? So how observability comes into the picture here? If I would have set up a proper monitoring observability solution, I would have checked this every now and then. And I would have had the chance to fix this issue even before the production impact would have occurred. And this is how observability can extend testing. I know this was a silly, hopefully representative example, but I've met with the same issue a little bit in a bigger, more real-life way in a project, a greenfield project I had 6 years ago. I joined to that project, into the team with huge excitement. I wanted to set up my best testing approach there. I learned by that time a whole from ISTQB, from conferences, and from colleagues and experience. So what I've done at that time, I set up a testing pyramid. I've automated actually each and every layer in that, except the UAT testing. Then I surrounded it with my management practices, DevOps practices. So we went into production with quite great confidence level. But when we arrived there, what happened? Of course, we had failures. And it was quite awkward because I did my very best in the pre-production testing phase. However, still we had issues. What kind of issues? Usually environmental related issues, like and a day we run out of database connection threads. One service from the many. After more than a week, actually. So we didn't usually do endurance testing, and not even that long endurance testing. So it turned out in production that's an issue. Another time we had expiring permissions for just a few user profiles that made our system dysfunctioning. And we had a whole bunch of other crazy one-timer issues you can see on the screen, and I believe you can imagine what I'm talking about. So this made me thinking about that, okay, I need to do something more over the standard pre-production testing practices. So I just think about that, okay, what would be that? How could I eliminate these issues? And then I recognized that I want to do testing in production. Not one-timer smoke testing, but a continuous testing, monitoring my system's quality, actually. So I've checked that what observability can offer. If you haven't heard about that, that is actually a practice providing the ability to measure and analyze real-time how a software behaves. It uses actually 3 techniques for that. By default, it collects actually metrics, logs, and traces. A couple of years back, when I heard this before, I had that intention, this is a system reliability engineer thing, and guys, I ain't no SRE. Leave me alone with that. It might be a buzzword, super interesting, but not for me. I'm a QA. However, the issues I had forced me to learn, actually, explore this area, and I did. 2 years experience I have with observability, and I can tell, actually, it is a practice that can perfectly extend our standard QA practices, further improving quality and resiliency of our software. And I was wondering where to start. There is an openly published document, actually. It's called Open Telemetry. It collects a whole bunch of frameworks, techniques, tools, usually vendor independent tools, open source technologies, that if you can connect these together and adopt it to your system, then you will have an observability solution. So I've done the same for setting up my self-detection system. What does it mean? I designed this solution for making my system able to recognize about itself if it's become unhealthy. Just a few words about my system. The most standard system, actually, worldwide, a web UI, and behind that, a whole bunch of backend systems we had. And behind those backend systems, of course, a whole bunch of databases, data warehouses, file systems, messaging systems, and whatnot. So I recognize that, of course, these could be the faulty pieces of my system. So I started here to set up an observability system for this. First of all, I've exposed health information from this, because that's the thing I wanted to observe. Health information such as, am I having healthy database connections? Do I have enough memory space, CPU to operate with? Am I able to connect with my partner systems through service discovery or some other channel? So I expose these with actually not coding, just with a few lines of configs, because the standard web development framework supports this out of the box. Exposing /health REST API, you can call in and it tells about itself, am I healthy or not? So I wanted to observe this. So where observability starts, I used a tiny library, Prometheus library, to grab the output of my health metrics, health information, and transform it to metrics, binary values, service by service, 0 or 1. Am I in trouble? Am I unhealthy? Or I'm healthy, running properly. So this is the thing I've exposed. This is another REST API that I can use with a Prometheus service, one from the OpenTelemetry family, a tool that can pull these metrics from each and every services, in my case, every half a minute. Then it stores it in its time series database, and I could use Grafana, another tool from this package, to visualize actually these. And I had this, a health dashboard. I could put this together with very standard patterns. It looks like that in the 99% of the time, green, shiny, and when there is an issue, it looks like that. It points out from the big system which is the faulty service, which became unhealthy. Once I had this, I needed more information about the service for knowing what is the root cause. So I used FluentBit, another observability tool, to pull logs from these services and just put behind, one click further away from my health dashboard. Once I've done that, I didn't want to, of course, sit in front of this health dashboard all the time, so I've just wired in an alert manager tool that is actually evaluating continuously my metrics, and when it's trouble, such as the health dashboard, alerts me, and in this case, in email alerts. So I want to stop here just for a moment because actually this is my money slide. With this, I could improve enormously the quality of my system, the quality and the resiliency of that. And I could measurably do that. I will get back to these measurements. But before that, I tell you, the next step came from one of the idea of my colleagues, who just came to me one day and said me, dude, if you have a self-detected system, cannot it be self-healing? And well, it made me thinking and made me start another journey. And I've set up my logic, how that would be possible. So if I have a self-detected system, obviously I have a self-detected issue. If for the given problem, I can grant an automated solution, put it into the script, check it if that's possible to execute it right out after the time of the detection. If there's no risk in that, maybe it's just a service restart from multiple instances of the same, execute it, trigger it automatically. This is, of course, the most ideal case. That's not really the real life all the time. If there is risk in the execution, maybe it's cleaning up caches or something like that, give it to your system maintainers and execute the automated solution for manual execution. Execute it when it's appropriate. And I tell you, if you cannot automate at all the whole solution, you're not in a dead end, because you have a self-detected system, and it tells you if it finds a reoccurring, a routine, a problem that actually occurred in the past a few times. And if that's a reoccurring problem, truly, you don't know the automated solution, couldn't develop the automated solution yet for that, you still can give actually hints, automated hints for your system maintainers with the alert messages. Actually, this and that is the problem, and dear software engineer, you can fix me with this and that step. Is it self-healing? Well, not exactly, or at least not in an automated way, but still it helps to heal itself. So it's not a dead end. And if it's not a recurring problem because it's a one-time or crazy issue again, then you still have, through the self-detected system, more information about the root cause. Metrics, logs, and traces, and pointing out which is the faulty part of your system. If you have the chance to work with your system architects, it's obviously a thing that you can recommend to figure out solutions that more like supporting the automated maintenance solutions. And as I promised, I'm getting back to metrics, measurements. So this is what is very valuable, I believe, measuring the impact. And I can recommend you two types of metrics regarding observability improvements. One is DevOps metrics, DORA metrics. If you check it on the internet, DORA metrics is a whole set of metrics you can use in your system. And regarding observability, I can recommend these two on the screen. One is actually, I will start with the second one, the time to restore. This is something I could enormously improve with observability solutions, because we could react quicker than ever on issues. Even many cases, we could react quicker than the business impact would occur. Therefore, we decreased actually the change failure rate as well. The rate of changes that caused business impacting issues in production. The other type of metrics is SRE metrics. As actually, observability is an SRE solution, and if you set up a system like that, you will by default have a whole bunch of SRE metrics about availability, healthy time, number and type of exceptions, and so on. Even latency information, if you're interested about performance. Now, if you put besides these values your costs, what you spent on efforts, on the infrastructure, you have actually the return of your investment. And this is something that is super important if you want to maintain good relationship with your business stakeholders. They understand this language, actually. Now, I put here a fourth category. It is a to explore category. It means I haven't tried it out yet. I just imagine that actually this could be the future of observability in connection with quality. There's a machine learning solution, predictive maintenance. Some companies do this, feeding with system data machine learning models that can help them to predict when and in which conditions the system tends to be fragile, unstable. And I've put this here because I see the connection with this and observability. Because we actually capture information about stability and resiliency of the system. So imagine this with huge systems. If you feed these models with SRE metrics, then most probably you can predict even better when your system starts to be fragile, and then you can set up an even more proactive way of maintaining your products. You might wonder why I've put here a category that actually I've never tried. I don't have proof if it's working or not. I tell you because I brought to you two main messages for today. One is quite obvious. I recommend observability, of course. But the second one relates to this and refers back to my opening quote, exhaustive testing is impossible. So I believe as a QA engineer, I have an important duty, besides doing my best in the pre-production phase, also exploring opportunities for support even better, a sustainable quality in production. And I know what will be my next area to explore. And I just wanted to raise thoughts in yourself too, thinking about that, how you are mitigating today exhaustive testing is impossible issue, risk. And if you don't do that, what will be your next area to explore? Thank you very much.
Thank you very much, Gabor. Okay, let's see if we have some questions for you. So we have the first one. This project has high costs. How can you justify these activities to your stakeholders, people who finance these activities?
Yeah, very, very good question. I always have this trouble in terms of any kind of QA improvement, because how do you prove that what you avoid, actually, issues, problems? In my case, how I did that, I collected data from the past, where we had, of course, a whole set of failing software. I made metrics from those, and I made metrics from those which are actually systems where I already set up a decent testing approach. So I generated with some business buy-in with that, and I could actually get the buy-in, the trust for investing into observability as well. And that's how actually my business stakeholders said, okay, try this out. You already proved your value with automated testing, pre-production testing approaches. And yes, we have these failures you listed there. So if you promise you can eliminate with observability, yeah, go for it. So that's the how.
Okay, thanks. Let's see the second question, which got, well, I think the 4 likes currently, or 5, so I will read that one. What is your favorite or preferable tool to use in your work?
Oh, it's too difficult question. Currently, I like to do, I like to practice infrastructure as code solutions. I don't want to mention tool because it's changing every now and then, which is the most popular and good tool for that. But I really like to work nowadays with those tools, set up my test environments automatically, test and throw it away, and that's all. So that's, yeah.
Okay, we also have a question regarding return on investment. So how long does it take to reach a positive return on investment?
I think it nicely refers to the first question, what happened after, what ROI I had, how I proved that it works after all. It took actually around 9 months, or at least I went back to my business stakeholders with my broader set of metrics, with proof that this worked. So it took 9 months to actually decrease time to restore by 30%, and I could actually drive down, change failure rate from 10% for a particular system to 4. So they said that it's awesome, and a year after, I could even increase the time to restore by 75%. That's kind of unbelievable, and even I could drive down change failure rate below 1%. So that was actually the ROI and the investment.
Yeah.
Part.
Okay.
Yeah.
Okay. Yeah. Cool. The last question is from Christoph. So, do you have an experiment, or do you have an experiment where observability was too much? So, for example, it caused slowing the system or similar issue.
Not with metrics, fortunately. I was very careful about not impacting the performance of the system. However, I made one mistake once with setting up log capturing solutions. Somehow I configured the tool in a faulty way. It started up, but started to log actually a whole bunch of unrelated issues about the log capturing tool itself. So it generated actually a big load on the local disk space. And it started to run out of space, and of course the products that were served around besides the service started to become fragile as well. I could detect, fortunately, quick enough this issue, and it didn't cause negative business impact. But yeah, it was something that was a mistake.